my name is Gary Petco and I'm your Knox County Schools Math Supervisor. Welcome to KCS Summer at Home Math video series that go along with your geometry packet you can find online at Knox County Schools website. This video goes with Geometry Section 2 on quadrilaterals. In this section, we're going to talk about four things: the polygon angle sum theorems, properties of polygons, proving that a quadrilateral is a parallelogram, and properties of rhombuses or rhombi, rectangles, and squares. Okay, quadrilaterals. This is going to build on much of your work that you really started with elementary. Quad meaning as a prefix for four, and lateral means across, so four across. So a figure that has four sides across. So if an object has four sides, it's called a quadrilateral. And then you learned in elementary and middle school and part of geometry already, that there are certain types of quadrilaterals: parallelograms, rhombis, rectangles, squares, kites. And each one had a certain set of properties. The three big ideas revolve around measurement, reasoning, proof, and coordinate geometry. Finding the sum of the interior angles, measures of any polygon using a formula, and then reasoning and proof. How do we use this certain information to solve problems? And the coordinate geometry, which actually is not part of this packet, we're going to leave that out because we're going to limit it to just the first four or five topics in here. And the first thing is the polygon angle sum theorem. Now that was a theorem which produced a formula, for better words, that told us how to find the sum of all the interior angles. So if we took all the four angles within a polygon or within a quadrilateral, really all the angles of any type of polygon, we could find the sum of what all of them add up together. If it's a quadrilateral, what all four add up together to equal. If it's a triangle, what all three add up together. If it's a pentagon, if we want to find out what all five of those add up together. This formula works. It says the sum is equal to, parentheses, n minus 2 times 180. Well, n is the number of sides. So if it's a quadrilateral with four sides, we'd put a 4 into this formula. If it's a triangle, we'd put a 3 in. If it's a pentagon, we'd substitute the number 5 in for n. We use that formula, and that will produce an amount. And that amount is the sum of all the angles in a polygon. And then we're going to look at parallelograms and special parallelograms. Parallelograms, and talk about the properties. Remember, those arrows on the side mean if you see two sets of sides with the same number of arrows, that means they're parallel. So this has two arrows on it, and the bottom one has two, so that means those two sides are parallel. On the side, these two have arrows, but they only have one, so these two are parallel. And then markings with the angles, much like congruency with triangles. If a side has the same number of tick marks, that means they're congruent. If angles have the same number of arcs, they're congruent. And then the property of parallelograms, the line segment that goes to opposite vertices, what's called a diagonal, because they're cross. The key thing with parallelograms, no matter what type of parallelogram is, the diagonals bisect each other. Remember, that's what since those marks are congruent on both sides, that says when they cross, they automatically split that segment or that diagonal into two congruent amounts. And then special parallelograms, this is one where we have a rhombus where all four sides are congruent. They also fit these properties we have over to the left, but in addition, they're all congruent. A rectangle, all four angles are 90 degree. And then finally a square, notice we have congruency and in terms of sides and angles. That means if they're all four 90 degree angles, that means it must be a rectangle. If they're all four sides are parallel, it must also be a rhombus. So it's kind of where certain parallelograms fit into certain categories. Okay, so let's see what we got. Got, again, key vocabulary to look at. Got vocabulary that come to mind: consecutive angles, angles that are beside each other. Isosceles trapezoid, similar to isosceles triangle. It means opposite sides are congruent. We've got opposite angles, opposite sides. These are key vocabulary that come in mind, and we've got some question starters to help you out with. That parallelogram with four congruent sides is an, what would it be? And if you can look back from the previous slide, You can see that which vocabulary would fit. You could look at a parallelogram with four congruent sides. Well, I wonder what that would be. Well, we've got a square has four congruent sides. A rhombus has four congruent sides. So it could be either one of those. The answers to these four questions are in your packet, but it gets your mind stirring with vocabulary. The thing I like with quadrilaterals, as we go to the next section, this gets us thinking about physical features. And sometimes math seems so what we call abstract, like you can't see it. But in this situation with quadrilaterals, it's talking about things that are physically built out there in these shapes. So if a structure, a building, a sign, some type of fenced area has one of these shapes, it carries on the same characteristics that we have right here. So quick review. As I said earlier, the sum of the measures of the interior angles of an n-gon, that's just what generically we say n-gon, like pentagon, hexagon, octagon. We don't know what type of side, so we just say n-gon, is collectively n minus 2 times 180. But here's another formula. The measures of just one of those, of a regular n-gon. A regular means all sides are the same. So because we have a trapezoid that has four sides, but all the sides aren't the same length. But a square is a parallelogram with a quadrilateral with four sides, and all the sides are the same length. So a square is an example of a regular polygon, where all the sides are the same length. To find out the sum of the measures of just one of those, we take that formula that we had earlier and divide it by n. Well, that kind of makes sense, because if it's a regular polygon, all the sides are the same length, and all the angles are each congruent. And if this formula n minus 2 times 180 gives us the sum of all the angles collectively, and they're all the same measure, then to find one, we take that amount and divide it by the number of angles or sides we have. And then last but not least, the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360. What? What does that mean? That means no matter what type of polygon you have, square, rectangle, triangle, pentagon, octagon, nonagon, any type of gon, always the sum of the measures of all, collectively, all the exterior angles, always, every time add up to 360. So an example, find the measures of one interior angle of a regular 20-gon. 20-gon. Well, once we said, that formula says whenever I see an n, that represents the number of sides, and they're telling me if it's a 20-gon, 20 is the number of sides. So I'm going to substitute 20 in for my formula. 20 minus 2, whatever that becomes, times 180, and then I divide by 20. So the numerator eventually simplifies to 18 times 180. That product collectively gives me the sum of all the interior angles, but if I divide by 20, because they're all the same, that gives me the measure of 1. So this handy formula allows me to find the measure of one interior angle of an n-gon. I'll use that same formula for 5, 6, and 7. Hexagon, 6 sides. 16-gon has 16 sides, and a pentagon has 5 sides. But what is the sum of the exterior angles for each polygon in x and 5, 7? Well, maybe that little last sentence might help you with that. And then find the measures of the missing angles. So I'll tell you, 9 and 10, you've got to find the total sum using this formula, n minus 2 times 180, and then use that amount plus the amounts given to you to see if you can find x. Okay, the next section in this part is properties of parallelograms. Going back to what characteristics do parallelograms follow? Opposite sides and opposite angles of a parallelogram are always congruent. Consecutive angles, meaning angles of one right after the other, one on the top and then one right below and on the bottom. Consecutive angles in a parallelogram are supplementary. Supplementary, remember, add up to 180. This follows right along the line with we had supplementary or parallel lines cut by transversal. Use consecutive angle concept. And as I mentioned in one of the previous slides, the diagonals of a parallelogram bisect each other, meaning they cut them in half. And then the last one, if 3 or more parallel lines cut off a congruent segments on one transversal, then they cut off congruent segments on every transversal. That'll come in handy in the proof part that we really won't get into in this section, but it's just something good to know. So again, an example, find the measure of the numbered angles in the parallelogram. Well, I've got 4 angles I'm trying, and one's been given to me. Well, I'm going to use these properties to help me determine that. One was 56. Look up here. Consecutive angles are supplementary and opposite angles are congruent. So there's a couple of ways I could find this out. I could look at opposite, where the opposite of 50, this angle down here in the bottom is 56, would be, whoop, opposite is number 2. So that must mean number 2 must be 56 also. But consecutive, an example of consecutive is 3 and this bottom one are consecutive, or 1 and this 56 are consecutive. They're supplementary, means they add up to 180. One of the beauties of geometry, the algebraic part of geometry, it usually revolves around one of 3 types of equality statements. Statements that are either equal, they add up, things add up to 180, or add up to 360. And in this case, if they're consecutive, I could take angle 3, whatever that is, plus this 56 degree, and that should equal 180. Or I could take angle 1 plus 56 and add it up and it should equal 180. Either way, they both tell me that angle 1 and angle 3 equal 124. All right, the next part of this is proving that a quadrilateral is a parallelogram. We've got certain rules, certain characteristics. A quadrilateral is a parallelogram if any one of the following is true. Look at that. So both sides of opposites, both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Consecutive angles are supplementary. Both pairs of opposite angles are congruent. The diagonals bisect each other. One pair of opposite sides is both congruent and parallel. Remember, a quadrilateral is a parallelogram if any one, just one of these are true. So, for example, must this quadrilateral be a parallelogram? Look at what's given to us in this figure. These same marks say these two opposite sides, opposite angles are congruent. Similar with these marks. So since that's the case, both pairs of opposite angles are congruent. Well, that's what we've got here. Both pairs of opposite angles are congruent. So this pair is congruent, and so is this one to each other. Therefore, it must be a quadrilateral, a parallelogram. Use that same concept with these rules over here. Keep in mind, it has to be just one of them. Okay, in the last section are properties of rhombuses, or also plural could be called rhombi, rectangles and squares. Much like the previous slide, this gets more specific about a certain type of parallelogram. A rhombus is a certain type of parallelogram, which means it follows the same characteristics as we had in that previous slide, but it's particular, it has only 4 congruent sides. A rectangle is a parallelogram with 4 angles, and a square is a parallelogram with 4 angles. So what are the measures of the numbered angles in the rhombus? Well, if it's got 4 congruent sides, and we know the previous properties, let's see, what's given right here? I'm given that angle right there is 60. Each pair, if angle 1 is 60, each pair of opposite, each diagonal of a rhombus bisect a pair of opposite angles. Oh, if it bisects, it cuts that angle in half. So if that's 60, that angle and angle 2 is a right angle, because right here the diagonals of a rhombus are perpendicular, so that means that angle 2 is a right angle, and that 60, that means that little triangle down here in the bottom I'm circling right now. Angle 2's a right angle, that's 60, well that must mean that has to be 30 for angle 3, because that's a right triangle. Use these concepts over the exercises 21 through 28, and once again we have the answers at the bottom, or at the end of your packet. Okay, to finish this presentation off, another quote, Edgar W. de Dijkstra, he's a Dutch system scientist. He said there should be no such thing as boring mathematics. Oh, I live, breathe, and sleep that, geometry students. Mathematics is beauty. It's all around us, and I hope that you find it and never get bored with it. Thank you, and enjoy this section. We'll look forward to seeing you in the next section.